Hello student, today I am going to explain the probability. The probability theory has its origin in 17th century. The king of France, who was fond of gambling, consulted the great mathematicians Pascal and Fermat for solving the gambling problems. These two scientists tried to solve the gambling problems using probability concepts, which led down to the foundations of the probability theory. Later on, during the 18th century, the great mathematicians like Bernoulli, De Moivre, Laplace and several others made valuable contribution to the development of probability theory. Professor R.A. Fisher, who can be called as father of statistics, introduced the empirical approach to the theory of probability and expanded its use in biology, agriculture, genetics and medicine. We have seen that the random experiment has more than one possible outcomes, and its certain outcome cannot be predicted before conducting the experiment. However, we can make certain statements as my chances of getting first class are good. The chance of today's rainfall at 4 p.m. is high. Possibility of Indians entering in the World Cup cricket finals is high. Such statements we can make. The theory of probabilities tries to measure the possibility of an outcome in numeric terms. Thus, the probability of an outcome is the numeric measure of possibility of the occurrence of that outcome. Unless we have numbers, we can measure chances of various outcomes. We cannot analyze them mathematically. There are several definitions of probability. We shall consider here the classical definition of probability. Classical definition of probability. Definition of probability. Or it is also called as mathematical definition of probability or probability of an event, or probability of an event. In classical definition of probability, it is assumed that the sample space under the consideration is equiprobable. That is, the sample space corresponding to any random experiments is said to be equiprobable sample space. See, equiprobable sample space. Equiprobable sample space if all the outcomes are equally likely or the probability of occurrence of every outcome is the same. Suppose omega is equal to, which contains the outcomes H and T. If we toss a coin, then we will get outcomes head or tail. Now, when we toss a coin, then the chance of getting head is equal to that of the tail. That is, probability of head is equal to the probability of tail, which is equal to 1/2. If we assume that the total probability is equal to 1, therefore probability of H plus probability of T, which is equal to 1. Here H stands for head and T stands for tail. Therefore, this sample space is called as equiprobable sample space. Now see second example. Example number 2. Throwing a 6-faced die, then the sample space will contain the outcomes omega is equal to 1, 2, 3, 4, 5, 6. Sample space containing 6 outcomes. The chance of any number appearing on the uppermost face of die is same. That is, probability of occurrence of number 1 on the uppermost face of a die is equal to probability of 2 is equal to probability of 3 is equal to probability of 4, which is equal to probability of 5, which is equal to probability of 6, which is equal to 1/6. Means the chance of occurrence of any number on the uppermost face of a die, which is equal to 1/6. Therefore, this sample space is called as equiprobable sample space. Each and every outcome of the sample space has equal chance of occurrence. Therefore, the sample space is called as the equiprobable sample space. Then, now we define probability of an event, or classical definition of probability. If a random experiment results in n mutually exclusive and equally likely outcomes. That is, if we consider any random experiment and that random experiment has n mutually exclusive and equally likely outcomes, out of which m outcomes belongs to the event A. Means m outcomes belong to event A. This event A is defined on the sample space omega. Then the probability of event A is denoted by P of A and A is defined as M by N. Here 0 less than or equal to M less than or equal to N. M means number of outcomes belongs to event A, and small n means total number of outcomes in the sample space omega. For any event, the probability always lies between 0 and 1. 0 less than or equal to probability of A less than or equal to 1. Means for any event, probability always lies between 0 and 1, both inclusive. Since M, total number of outcomes belongs to event A, is always less than N, that is total number of outcomes in the sample space omega. Therefore, the probability of any event always lies between 0 and 1. Okay, now we see example on this classical definition of probability or mathematical definition of probability. It is also called as probability of an event. Now, for example, suppose a unbiased coin is tossed 2 times simultaneously. If a pair of unbiased coins are tossed, then what is the probability of occurrence of bit number 1, both heads, bit number 2, at least one head, If we toss a pair of unbiased coins simultaneously, then we have to find out the probability of occurrence of at least one head and both heads. Now for this example, first we have to write sample space. Sample space corresponding to this problem is omega is equal to, which contains the outcomes HH, HT, TH and TT. This is the sample space corresponding to the given problem. This sample space contains the total number of outcomes 4, that is n is equal to 4. On this sample space, for bit number first, we define event A, which is equal to, event A is equal to both heads occurs, both heads occurs, then event A contains the outcome. In the above sample case, there is only one outcome which contains both heads, that is A is equal to HH. And in this event, there are only one outcome, that is M is equal to 1. Now, by definition of an event A, we have probability of event A is equal to M by N, which is equal to 1 upon 4. Probability is 1 by 4. N is equal to 4 and M is equal to 1. Therefore, probability of event A is equal to 1 by 4. Then, second bit is, what is probability of occurrence of at least one head? Now, we define another event on this sample space. Let B is equal to at least one head occurs. At least one head occur. Then event B contains the outcomes. B is equal to, which contains outcomes HH, then HT, and last one is TT. Here M is equal to 3, means total number of outcomes in the event B is equal to 3. Therefore, by definition of an event, probability of event B is equal to M by N, which is equal to 3 by 4. We have this probability, that is probability of occurrence at least one head is equal to 3 by 4. M means total number of elements belongs to the event A, and small n, which is equal to the total number of outcomes in the sample space omega. Okay. In this section, we see some examples on classical definition of probability. The first example is, 4 cards can be drawn at random from a pack of 52 playing cards. What is the probability that the 2 cards are red and 2 are black cards? Now, the solution for this problem is, in the playing cards, there are total 52 cards, and which contains 2 colors, 26 cards of red color and 26 cards of black color. Now we have to draw 4 cards at random from a 52 playing cards. Now the 4 cards can be drawn from a pack of 52 playing cards in 52C 4 ways. This is the total number of ways of drawing a 4 cards from 52 playing cards. 52C 4 ways, that is n is equal to 52C 4 ways. N is the total number of outcomes containing in the sample space omega. Now to find the probability of required event, for that first we define one event. That event is, let capital A is equal to 2 cards are red and 2 are black. 2 are black. Now, in a pack of playing cards, there are total 52 cards. In 52 playing cards, 26 cards of red color, red, and remaining are black color, that is 26 cards are of black color. Now we have to draw 2 cards from 26 red cards. I need 2 from 26 black cards. 2 cards can be drawn from 26 red cards in 26C 2 ways, and 2 cards can be drawn from 26 black cards in 26 2 ways. Therefore, M is equal to number of elements belongs to the event A, which is equal to what? 26C2 into 26C2. Therefore, probability of an event A is equal to what? M by N, which is equal to 26C2 into 26C2 divided by 52C4, which is the required probability of an event A. That is probability of getting 2 red cards and 2 black cards from a pack of 52 playing cards. Okay. Now we see next example on classical definition of probability. Suppose a die is thrown, then what is probability of getting an odd number on the uppermost face of a die? See, second example, a die is thrown, then what is probability of getting odd number on the upper face of a die. Now, first write down the sample space for the given problem. Sample space for the given problem is what? Omega is equal to, if we throw a die, then sample space will contain the outcomes 1, 2, 3, 4, 5 and 6. we have to find out the probability of getting odd number on the uppermost face of a die. Therefore, we define event A such that event A is equal to what? Odd number appears on the uppermost face of a die. Uppermost face of a die. Then event A contains the outcomes A is equal to odd numbers from the sample space omega are 1, 3 and 5. In sample space there are 6 outcomes, and in event A there are 3 outcomes. Now, by classical definition of probability, we have probability of event A is equal to m by n, which is equal to 3/6, that is 1/2. This is the probability of event A.